All right, we're going to wrap this up with industrial control systems vulnerability assessment. Now, industrial control system, look, if you look down here at this image, see buttons and widgets and dip switches and levers and all kinds of stuff. Well, that's because industrial control systems are, well, generally used to control industrial equipment. So a lot of times this will happen in industrial plants, like manufacturing plants and such, because a lot of these ICSs, industrial control systems, they're just little computers. One common type is called a programmable logic controller, or PLC. And PLCs are used a ton in manufacturing and industrial plants. They're just little computers that run machinery. Think of conveyor belts. They run conveyor belts, and they run industrial furnaces, and they run all kinds of equipment. But they're just little computers that are programmed to run this equipment. And they do plug into a network so that they can communicate with each other. There are also remote terminal units, or RTUs, and they do the same thing. So when we have these types of computers that are on a network, hey, they communicate with each other. Is that network separate from our office network, let's say? Because it should be. They should be completely separate. If not, and they are interconnected, then some device over here on our user network could gain access into these devices and try to take advantage of them, try to break into them and change the programming to cause mass mayhem in the industrial sector. It could be very well done. If you think about Stuxnet, and if you're not familiar with Stuxnet, you should definitely read up on it. It's pretty cool. But it was a malicious worm that was targeting ICS systems, and more specifically, SCADA systems. And that's supervisory control and data acquisition. And these SCADA systems are just additional ICS systems. And Stuxnet was a worm that was targeting these systems. And it was targeting nuclear centrifuges, to be more exact. So again, if you think about this though, in industrial systems, and this also goes into the world of oil and gas and electric, these systems, especially SCADA systems and the PLCs and RTUs, are all used not only in industrial plants and manufacturing, but also the world of oil, gas, and electric, generation and distribution of these systems. And when these systems, like our PLCs and RTUs and our SCADA systems, are developed, well, security isn't always top of mind, because generally these devices are on private networks so that the bad guys can't gain access to them. That's the idea anyway. But even though that is there, people will still at times plug their computers into these networks in order to manage these devices. And when you do that, if there was something like a worm on your computer, it could then gain access to these devices. So we're trying to combat like poorly written code, weak protocols that are being used. And if these systems are internet connected, then they are definitely open to attack from the public. So we think about that. Now, how do we test these things? That's a good question. Let me make a little room and we'll talk about that. So how do we test these? Let's just get rid of this here. So when we're testing, there's really two different ways that we can go about doing this. One is a manual assessment. Let's change colors here. So a manual assessment, this is when we are evaluating the security of an ICS device. And this focuses on the device, its operating systems, and the configurations on the device. So we're really looking at the operating systems and configs. Now, with the operating systems, is it up to date? That is a really good question. Are the configs secure? We don't have plain text passwords and such in them, things like that. But then, number two, the other option is called port mirroring. And this is where we use a network switch that all these devices are connected to. So we'd have these devices on here all plugged into a switch at various locations so that they can talk to each other over the network. Well, the thing is, I can actually turn on what we call a span port or a mirror port, and then plug a computer into that, and I can see a copy of all the traffic going to and from a specific device. Well, I would do this so that I can analyze, so we'll put up here, analyze network traffic, so that I can analyze all the communications going to and from these devices. Is this normal communications? Is there communications on an abnormal port? Is there brute force attacks going on? I can actually see what's happening across the network by using port mirroring. So really, we want to do both of these. Manual assessment, make sure our OS is up to date. We're using security configs, and then we can use port mirroring to perform packet analysis, like we did with Wireshark earlier in the course. We used Wireshark to take a look at HTTP methods, if you recall. And so the idea is you could use Wireshark and you could go through and analyze that network traffic, or even feed it into an application that'll analyze it for you and find out if there's not nefarious activity going on. All right, so that wraps up our scanning methods. That means next up we're going to start, doing some scanning. We're going to work with Nikto. Nikto is a tool that is a web application vulnerability scanner. So we'll start doing that in the next nugget. See you there shortly. Thanks for watching, and subscribe here to get the latest from CBT Nuggets. And if you're interested in IT career or learning more about IT in general, hey, swing by cbtnuggets.com and sign up for a free trial.